Hello everyone, welcome back to SDN Bits. In this channel, we discover network automation and programmability concepts, and in today's video, we are going to continue exploration of PYEAPI library for Arista EOS automation. In the last video, we have already explored some of essential methods on how to send operational show commands to the devices and retrieve their output, and also to send and push configurations to our devices via PYEAPI scripts. And we were following this particular quick start in documentation of PYEAPI to use these examples and construct our own scripts. And now we will continue from the point where we left off last time, and which was basically this section. We have discovered it completely, and if we continue, if we scroll down below, we will see this section of API method, right? So the PYEAPI library provides both a client for send and receive commands over eAPI, as well as an API for working directly with EOS resources. Right? So we already explored the send and receive commands, and now we're going to explore the API to access directly EOS resources. The API is designed to be easy and straightforward to use, yet so extensible. Below is an example of working with the VLANs API, right? So this is exactly the same scenario like my previous video, and I have again my Spine 2 device up and running, Leaf 3 and Leaf 4 also up and running. I am storing my Python script on the bash shell of Spine 2 on the Linux subsystem of Spine 2, which is our CentOS 7 Linux operating system environment, and I'm running my scripts also directly from there. And we'll just go ahead and do the same thing using our script to explore this API method. Good. So if I open up my Spine 2 device, which is my automation controller at this point, you might recall this file which we created in the last video. This is a basic Python script file where we just point out what we want to do with our device or devices. And let's open up this file again, and now let's play with API method. So I will just comment out what has been done before in this file, because we need them as a note, but not not for execution. And as you can see, I will not comment out this part because we're still working with the Leaf 3. It can be Leaf 4 anyways. And this node object variable will stand right here. And let's just continue looking at this script. So the connection to the node is already created. Let's go down below. And now we can start exploring this API method. So the first thing here they mentioned is get the instance of the API, in this case once. Get the instance of the API, right? Very important. Let's comment this, get the API instance. And let's see. So VLANs, I always indicate my variables in capital letters, in uppercase, because it's more convenient when it comes to readability of the code. Node, API method, and VLANs. Let's see. So let's now print it. Pretty print VLANs, and let's see what it shows to us. Save the file, execute the script, and there you go. So PYEAPI, API, VLANs object at this particular point. Now we will go ahead and retrieve all VLANs from the node. Return all VLANs from the node. So to do this, we have to basically run VLANs. VLANs get all function. That looks like a function. I don't need this anymore. And I think we should store the output of this So let's say VLANs here, and let's change this to VLAN instance. And let's try to pretty print VLANs variable file. Output, sorry. Good. Execution. Name error VLANs is not defined. Okay, I'm sorry. I'm stupid, yeah. I should have said VLAN instance. I forgot to indicate this. VLAN instance, right. Now this should work better. Okay, there you go. So this API method allowed us to retrieve all the VLANs in our leaf3 device. So we have VLAN 100, 200, and 4094. Okay, very good, very good. What else we can do here? We can return a specific VLAN from the node. Specific VLAN, okay. So this is very long and inconvenient to read. Maybe we could shorten this a little bit. Or, okay, whatever. So this, we don't need this anymore. Let's comment it out. And VLAN instance, let's say specific VLAN. VLAN instance get. So by using get function, we can just get whatever. Well, let's say 200. And Control X, yes. Sorry, I forgot to print it out. So pretty print specific VLAN, Control X, yes. Okay, works very good. Now we will have output only for the VLAN 200, and we can use this command to create this function to create a new VLAN. Let's go ahead and try it. Actually, why not? So no. Let's say create VLAN and VLAN instance create let's say, I don't know, 500, whatever. So it should create a VLAN, and to check it, we will run this command. And we can actually remove it from here. So first we'll create a VLAN, and then we will try to fetch data about this VLAN, and just to check if we actually didn't fail. Yes, it is created. So it works perfectly good. What else we can do here? We can set the name for our VLAN. So first we create, then let's say set VLAN name, and basically VLAN instance set name, set underscore name function. And so for VLAN 500, I want the name of, let's say, test, or let's say PYEAPI, right? Control X, yes, run the script. Yes, perfect. We have VLAN 500 and we have its name. Can we delete the VLAN? How it actually works? Is there a command to delete? Let's presume there is a command to delete, and now we don't need to create anything anymore. Let's say delete VLAN. They don't specify anything like this in the documentation example, but I will go ahead and just trust my intuition to do it a basic delete function, which hopefully is there, and it should delete the VLAN, and we should not get any output. If it's going to be very interesting. Control X, yes. Let's see. None, which means it worked, right? I do believe it did, because we can also check it via CLI. Show VLAN what summary? What is it? Show VLAN, just show VLAN. Okay, yeah, that's right. That is right. It works. So you can use delete to delete, right? Very basic functions for VLAN manipulation. I wonder what else we could use. Like in this case, they show us the VLANs API, but is there what else is there? Like I would love to understand it. I think we could check it, though. I forgot the command to check it, but there must be a command in Python. Oh, sorry. To check what we could do. I think it was type. No, type will show us the type of Python object. In this case, it will probably be a class or something like that, but I would know. I think it was dir. The dir will list the capabilities of certain class or function. Let's just try to do it, actually. So. PYEAPI. What if, say, we can comment this out? There's really nothing else to do here. This one instance. So pretty print, maybe dir. I don't know, dir of one in instance. I guess I might be wrong. I think I'm wrong, actually. No, that works perfectly fine. So this is it. Yeah, I found this delete function with intuition, but now if you specify the dir, you can get the list of possible functions for this particular instance, which is the VLAN. So for VLAN, we have this kind of classes here, and when it comes to functions, you have like a trunk group, you have config, you have configure interface, configure VLAN, you have a lot of things here, items, keys, node. Wow, great. But what if I want to know, not just for VLANs, but what else is there, like for us? What else we could possibly do with this API? Like, should I dir the API itself? Can I do that? So pretty print dir node dot API maybe? I'm not sure. I don't think it will work, but let's try it out. It does. And what else? It does work, but this is not the output I was looking for. I mean, this shows the subclasses, if I'm not mistaken, for the operation of API method, but I would like to see which methods are available, what else we could, which other instances of API are there except for the VLANs, which they have specified here. I don't really see much. No, this is not what I need. What else we could do here? Node API. Node, so node object. So, okay, I think I know what I want to do here. So if you go up and if we just print this VLAN instance, I think it showed us the function path. But if I run it without specifying the dir, I should be able to see the syntax error. Why? I believe I did it before, like it shouldn't have occurred. Preprint VLAN instance. Because I have to, my stupid mistake again. Let's clear this. Again, I am mistaking something. No such file or directory. What do you mean? No, it's something. There's something stupidly wrong. What else? Ah, of course, a typo. Yeah. So here we can see first we go to PyEAPI module, and then we have this API method. What else we have? Like it's VLANs in this case. I understand, but what else we have here? So I think to understand it, we have to. Can I just run it here? Python 3. I could import PyEAPI, and I could dir PyEAPI dot API, I guess. PyEAPI has no attribute of API, but it has though. Like, okay, what if I just okay, here we can see what methods we have: config for, connect, connect to, which we used, eAPI lib, load config, and utils. Yeah, but what about API though? Like maybe like this? No. PyEAPI dot API. Okay, because it's not. Yeah, I mean we could do this, for example, maybe. Yes, this would work because we can see that inside PyAPI we actually have connect, and even connect to would work. In connect to we had multiple things, but it doesn't show me the methods. Like this is what I want. This shows me the classes which compose the connect method, which make it operational. But what I'm searching for is what other options do we have. Okay, so I will try to find out afterwards. But for now, we have already explored this API method again. Again, very basic usage, guys. You just have to specify the node object, and then you are calling this method, and then you can specify whatever is it there. And this is how it works, basically. I am... Okay, so let's go to the next page in this documentation file. PyEAPI configuration file. We already did this in the last video. If you haven't seen, just please watch the previous video, which has to be part 4. This will be part 5. The modules. Okay, let's go to modules. Those are the requirements for PyEAPI. So you need Arista EOS version which comes from 4.22 or later. eAPI enabled for at least one transport. By default, HTTPS server is enabled. So if you just issue management API HTTP commands, no shutdown command, you will have already eAPI access. Python 3.7 plus. In my case, it has to be 3.9. The latest one should be 3.12 or 14, I don't remember. PyEAPI requires the net address Python module, which is automatically installed when you install PyEAPI package anyways. So no need to worry about this. We have some configuration examples using PyEAPI, configuring subinterfaces using Python client for eAPI. So let's see how these configuration has been made. Subinterfaces can be configured on Ethernet and port channel interfaces. To do this in PyEAPI, simply call create or delete with your subinterface name. Subinterfaces require that the primary interface be in a routed mode, which is, in our case, all of our interfaces are in routed mode because we're running layer 3 leaf and spine topology. At this point, okay, subinterface require, okay, we did this. We have to connect to device, nothing special. And again, using API methods, finally we have something else than VLANs. I was looking for this. IP interfaces option, we can create subinterface. We can create an interface, sorry, not subinterface. And then, using this command, again, interfaces, we can create subinterface by specifying it in a CLI syntax, right? So let's go ahead and do it for our leaf 3 device. At this point in leaf 3 device, let's just clear the screen, show IP interfaces brief command, and as you can see, I do not have any subinterface at the moment, but I could create some for demonstration purposes. This is what I will do. I will go to spine 2, I will open up my test script. I have commented pretty much everything here, so Okay, so suppose that nothing happened and just we're importing the PYEAPI library, the pretty print for indentation-based output for readability, and then we're instantiating a node object which connects to the leaf3 device, and skip everything else because we don't need them. And now let's do it. Node API method interfaces create, let's say Ethernet 5.1, right? Let's see how it goes. Okay, so we don't need to, actually I do need to run this command as well because, okay, I need to change because my Ethernet 5 interface is not routed port, it's a switched port. So it's a switch port, and we can use all the other interfaces. So let's try to use Ethernet 2, right? So Ethernet 2, let's try. And what is it? It's just a command we're running. And we have to verify this, right? We have to verify this, let's say int interface we'll send in show command by using enable method to see what happened. And just send this command show IP interface show IP interface brief, right? Yeah. Back to the script. Brief. Send this command and print. Print the. Sorry about this. Print the interface output. Good. So basically, we are creating a new subinterface, and then we are issuing show IP interface brief command from here to see to verify the output and to see if we actually created the file, the subinterface. So let me run the script. Name node is not defined. Ah, my bad, my bad. Capital letters. Node. Control X, yes. And for come here. I don't really see it. Where I should look at? I don't see that. I can see my Ethernet 2 interface, but I don't really see a sub-interface here. Maybe because... Let's check the CLI. Yeah, it is created, but for some reason... maybe it's because... down dormant. Okay, sorry. Down dormant, maybe. Ah, yes, sorry. I'm just blind. It's right here. I am just blind. Yeah, it's right here. So now let's try to remove it, I guess. If there is nothing else we can do, we can set encapsulation. Okay, let's try that. Let's set encapsulation. Let's do it. No, how do you do that? You go down and node API interfaces, set encapsulation. So we don't need to create this anymore, it's already there. I'm just gonna node API interfaces set underscore encapsulation encapsulation 4, which is VLAN 4, right? Let me just fix this part. So interface Ethernet 2.1 4 VLAN 4. Let's say 100 in our case because we already have this VLAN. What else we can do here? Using the delete in the same format as create, we'll remove the subinterface. This is what we will do afterwards. For now, let's formality automation. What can we do? Reference the user manual for the version of EOS. User manual, of course, user manuals. Let's see how it's gonna end up. And if I go to my sub interface, I should be able to see what I should be able to see here, I see that there is some address, empty. All of those things were derived from the parent interface, obviously. But when it comes to the encapsulation, how we can detect the VLAN? Maybe I'm running the wrong command. Probably yes. So show interfaces, maybe Ethernet 2.1, and can I see the VLAN here somehow? No, I can't show interfaces. VLAN maybe VLAN 100, and is up. That's also a different issue. Show VLAN basically, yeah. I think here we should be able to see. Yes, there is port channel 100 and Ethernet 5 because it's been assigned there, but I can't really understand how I can. Okay, show configuration, show run interface Ethernet, the best way. 2.1, yes, that's right. So yeah, now let's remove this config because we don't need it. So all we have to do is basically just issue the remove command here. So I will just get rid of this. And here, instead of create, I will call the delete function. And I will save it. I will say yes. I will run the script. And I should not see this interface anymore, which is right. Which is true. Good, good, very good. Let's continue. Contribute. Okay, I think that's it. Yeah, that's it. So from now on, it's just information about on how to contribute to the documentation, to PYEAPI, library itself, and yeah, nothing else. So here in the quick start, if I'm not mistaken, you can find some examples on official PyEAPI folder of Arista EOS plus repository and GitHub. And here you will have very simple examples on what else you can do with it. So let's just go over through that. Let's open the simple one. What the simple one shows us, we have a connect option. Now the connect option is different to connect to option. And to demonstrate it, I will have another script on our Spine2 device. So we have the test script, and now let's create a new script. Nano, let's say simple py, just exactly like in the GitHub repo. And the same shebang lines can be applied as well, although not necessary. User bin python 3, good. They are importing this print function here. And do they actually use it? They must use it, but in our case we don't really care. Import PyEAPI, right? And from prettyprint imports prettyprint. Now, what is the difference of connect method in comparison to connect to method? Connect to needs an inventory to retrieve device settings from, right? In our previous examples, if you look at the connect to function, we need eapi.conf file with default device settings already prepared. So it needs a source of truth to gather info and work with that data, right? But the connect function is simpler than that because it does not need anything in advance. It does not need any type of configuration file consisting of device settings because we are specifying all of them in the script itself. So I will just go ahead and I will follow the script and I will create a similar one. I am creating a connection variable which will store the instantiation of our node. I will say PyEAPI connect, and here we identify the host loopback address or any other address to reach the device manually. So my leaf 3 device has the loopback address of 192.168.0.5, right? And in the output variable, we will store the output of show commands we have sent. And to send these commands to our device, we'll use execute function. So I'm opening this up, execute. To send multiple commands, we'll obviously use the list, creating a list and specifying each command as a string, obviously. So show, let's say something different, show ARP, right? Let's see the ARP output. Now, the thing to point out here is that, as you can see, unlike the connect to method here, using the execute function, we are specifying CLI commands one by one. So this is more procedural, let's say. We have to specify each procedure. So first, when you open the CLI session to the device, you have to specify enable command to drop down to privileged execution mode, and then you are specifying show commands, right? Exactly the same thing happens here, procedure. Step 1, step 2, right? Good. And now we have to just pretty print the output and see what is going on and how this output differs from the connect to method. Let's see if it differs or not. I am going to convert this script to an executable, and using the shebang, automatically the script should be executed. So simple py, unauthorized, unable to authenticate user, bad username, password combination. Because, as I said again, it does not use any preloaded configuration file, and it has nothing to do with the eAPI.conf file, which stands there and has all the credentials and device settings specified in it. We, in the connect method, must specify everything explicitly. So I will go back to my script and I will specify username and password. And let's see, can we actually get through without specifying transport method, which should be HTTPS by default. So I'm doing exactly the same format. The username will be Arista, and password will also be Arista, and that is pretty much it. Control X, yes, clear the screen, execute the file, now it works. So we don't need to specify explicitly the transport method because it's HTTPS by default. And we have a different type of output. We have a different type of output, guys. This is different than what we had with connect to method. So let's just try to understand what is exactly different here. Let's just compare two methods head to head and see what is wrong. So I will open another console session to my spine device, and in this session I will run the test.py script, which consists the connect to method. But before, just to make it completely equal, I will fetch the ARP output from the enable method, right? So output of, please just show me the output of ARP, show ARP command. And I don't want to see specifications here. I want to see entire output. So yes. And let us just run this file, test py. Good. Actually, let me do it again so I will have more clear output. This is the difference. So this is, and this is the one with connect. So this one is, sorry, they are dependent scripts. So this is a problem. This is a problem. We should not see this problem. I have an idea. What if we just use leaf4 to run the script? We could do it, but let's just compare it even here. Like this is it, and then we will have this script. You can see the brevity of the output in the connect option, and when it comes to connect to option, we have much bigger output. Sorry, because there is show IP interface brief command also executed. Let me just comment that out. So yes, just get rid of this. Control X, yes. again, clear everything. So connect, first we'll execute the connect to method, right, which is a test py file, and then we will execute the simple py file, which is just a connect option. And let's now compare the outputs. In this particular output, we have a list, as we noted before, but here we don't have any list. It's a JSON object directly. I mean, it doesn't start with the list, but bear with me. So encoding is JSON here, and here we have a JSON RPC entry. It means that here we are using an RPC request reply methodology to communicate with the device, which is different to what we have here. The result key is present in both cases. However, in this case, we have just a dictionary object as an output, while here we have a list. Now, this is interesting. Here we have a list, different. And within that list, interestingly, we have this particular empty bracket, which is what, I don't know, we will see. And everything else is just an ARP output, which should be same for both cases, and it is the same. Yeah, except of like the age values, which makes perfect sense. Okay, so the RPC reply is different than this reply, which is just HTTPS reply, let's say. And if we look closely, how do we access specific entries here? We should specify the list first, then the result, and then let's say I want to know the MAC address. I would specify the IPv4 neighbors, and then again the list, and then the hardware address. But here it would be obviously result, and then list index 0, and then IPv4 neighbors, and then again the list, and then again the hardware address. As you can see, these are two different outputs because they work in a different way. Now, the pros and cons, when it comes to pros and cons, the connect method has a pro of being fast. You don't need additional eAPI.conf file to rely on. You specify everything in your script, and you have fast access to your device, and you can retrieve everything pretty fast. The cons are obviously the scalability. This is not a scalable option to indicate all of your devices in the script, all of their host names, all of their credentials. This is inefficient and also unsecure because you wouldn't like to have your credentials specified in the script itself. That is not a secure way of doing things. So that would be a con. And obviously, the pro for the connector method would be having a dedicated source of truth file where you can store all the device settings and link this file to your main script, and just by changing one source of truth file, you can have multiple scripts linked to it and they will act accordingly. And it is a very scalable and secure way of doing things. So I would say if you have a large scale environment, you should use connector method. However, if you have a simple environment consisting of a few devices, you can go ahead and use the connect method. So what else we have here? If we open up the simple py script, is there anything else that we can do? Nothing really. Let's go back to examples. Let's see the Glance API. I think I already used this. We have already done this. It was displayed in the quick start file, but here you have like additional options. You have like a little bit more advanced, let's say, scripting, like you can get a list of LANs and then you can iterate in this list and print each LAN. So this is nothing special really, nothing different. We'll do much more advanced scripts in the future. No worries about that. What else we have? Like sysmac.py, what is it? So again, just the connect method, sending show version, we've done this before. Now, there is one thing I haven't mentioned, and this is the load config method. So you can create a file in your directory, in any directory, doesn't matter, which will be your, let's say, private or dedicated source of truth file, which is not the eAPI.conf. So by default, the best practice states that you should have a eAPI.conf file. You should create necessary environment variables. It must be stored in those places. This is what you should do, and this is what we've done in the previous video. But it is worth mentioning that if you really do not want to create this like files and only for testing purposes, you need a simple inventory file to just run your script and see what's going on. You can use this load config option and this nodes.conf file. It can be any file, like you can name it as you want. So let's just create a really simple example. So in this particular directory, I will just create a new file which is called nodes.conf, right? And here I will just specify this connections, and if you can see, this is how it looks like. So I will just copy paste this to my file, and sorry about this. This is not what I wanted to do. I've Control C again, Control V. I am having some stupid issues with my copy paste procedure again. What is wrong with you? Okay, copy, good, and paste. Nice. Yeah, we could specify it like leave leave 3 in our case, and leave 4, right? And host IPs would be 0.5, username Arista, and password is also Arista. The same applies here, almost 0.6, username Arista, password is Arista as well. This is a dedicated conf file, which is a simple source of truth, exactly the same structure and syntax with the eAPI.conf file. Nothing is different. The only thing is that you can freely move this file wherever you want, and you have to explicitly specify this command, because by default connect to method would search for eAPI.conf file as per environment variables. But here, if you don't have that file, you just have to specify it explicitly. And to do this, if you go to the script, let's say to test.py, as you can see, here we should go up. Yeah, here we didn't specify anything else, but in another case we'll do something like this. Node. No, this one, we don't touch this one, sorry about this. Yeah, so if you look at this file here, you will see that, no, sorry, not this one. Yeah, load config method, right? Load config. So opening up this file, sorry about this. Okay, come here. It would be PYEAPI dot load config and specify the name of the file, nodes.conf. Good. And now, if you run this command, if you run this script, sorry, it will use the nodes.conf file to check to retrieve the leaf3 settings and to connect to it, right? So I will just save it, and to test it, I will do this thing. I will go back to my eAPI conf file, and I will comment this entry for leaf3. So it cannot use API conf file to fetch the host name of the IP address of leaf3. So I will just save it, and I will see how it's going to actually work out. Let's see. So PyEAPI scripts ll, and now let's try to run the test py. Aha, connection profile not found in config. Very, very interesting, because it looks at eAPI.conf file, but I told him to not look there. I think it happens because I have already specified the environment variable and it watches there. But can I somehow override this behavior? And I would like it to really focus on the nodes.conf file. Let's see how I could possibly do it. Now, everything is here. Like, you should focus on this file. Now, maybe it actually did focus on that file. How do we know? I believe, yeah, we should completely remove that, but I don't really understand why not to just look at the script. Interesting. Very, very interesting. If you say leaf 4, it should work, because it will go to eAPI conf and leaf 4 is not commented. There you go. But yeah, this is my thing. Like, it should work with leaf 3 also, because it will go to the eAPI conf file, it will see it should see, okay, maybe it's not smart enough to see it's commented here, it means I should look somewhere else, and somewhere else is this notes.conf file. So I will just we'll just send an error message to the user specifying that I couldn't find the leaf 3 settings. That's easier for him. So it's not really that smart from that perspective. Interesting. Okay, so but at the end of the day, you understand what's the difference, right? So nothing special. If you didn't have API conf file, it would basically go to nodes conf file, and nodes conf file it would derive the settings and just use that to connect to leaf 3. That's very, very simple. I don't really think it requires a certain demonstration, right? I mean, I've shown you how to like create this entry on your file, and then you should be okay to go with. So I will just go ahead and revert my changes on eAPI conf file by uncommenting these entries and saving it. Good. What else we have here? We have seen this one, this one, this one, this one, and the last one is getConfig. Now, getConfig is a really, really convenient function. The difference of getConfig with the running config and startup config functions right here is that it shows you the active configuration. It returns active configuration. And let's go ahead and actually run it. So I will open up the spine device again. Sorry, what is it? The PYEAPI scripts, clear, nano test, py. And if you go back to our examples, and if you open up here, it's very simple. All you have to do is basically ready print, or you can say output. I actually have to comment out something here to be able to use output. Or let's even say config, not even output. Let's call our variable config. CPG, shorter would be better. Is basically just node, again, nothing special, and indicate the function name, the method name, getConfig. And which config I want to get? I want to get the running config. Now, if you have paid attention in my videos, I always write the CLI command name until the end, because we do not have option of reading the shorter versions of commands, like in Cisco, for example. So I could say run, just, or show, I could say show run, or I don't know, show IP into brev, PR. It wouldn't work in Arista EOS because Arista EOS demands you to specify a full command without any syntax errors or deficiencies, which is actually very convenient. I mean, not very convenient from the perspective you just want to have a lot of commands, but remember, this is an automation script. And in automation script, you have to specify a command once. And it's okay to write everything because it's not a CLI. You don't do it every single time. So I would say the short command formats are very convenient for CLIs, but for automation purposes, it's not the end of the world if you have to specify an entire command in full of its lengths. So yeah, just specify it once and that's done. Everything else will be done by the script. And also it just looks complete, it looks better, it looks nicer. I guess. Let's just print the CFG file and see what is going on here. Control X, yes. Run the script. Yes, perfect. Now I said print. I should have said pretty print because this is very, very unreadable. So let me just do it real quick. It should be pretty print. Control X, yes, clear. And the command would be test.py. Now that is this much better. So we can see the running configuration in much more readable format. And so I would like to see this output exactly as I see it on the CLI. So if you issue show running config command in your CLI, you will see it like this. There are no exclamation marks or no quotation marks enclosing each command as here, right? You can see the difference. We don't have these symbols. We don't have these exclamation marks all the time. Let's get rid of that and let's have this clear output like in the CLI. And to do this, I have to get rid of the prettyprint function itself because prettyprint makes sure we are in the list. And we'll use the Python's built-in join function to join the next line symbol and to get rid of unnecessary symbols. So I will go to the script itself, and let's say, first of all, this is an output that we are storing, and this output is with extra symbols and white spaces, whatever, and we want to make it clean output, and the clean output will be our config file, running config, let's say. So the running config will actually be this particular white spaces being removed from it. So I will say the next line symbol, join, and output file. So it should join all the next lines, and it should get rid of the extra symbols in our config file. So we'll get the clear show running config output like we do in the CLI. And obviously we don't need the prettyprint function anymore. And this should actually work. So now let's just save the file and run it. Perfect. As you can see, now we have a clear running config output exactly as in the CLI. So yeah. So that would be it for today. Again, I've made another long video. Sorry about that. I will try to speed it up so that you don't really have to torture yourself with wasting your time here. In this video, we have explored many other possible PYEAPI methods and functions to automate Arista EOS devices, to manipulate the gathered data, and to have desired output states, let's say. Thank you very much for watching this video again. And as you can see, we're diving deeper and deeper to Arista EOS automation ecosystem more and more by each video. And in the next video, I will create a script which will retrieve running configuration from all of the devices in the lab, and it will store them in a text file. So basically, I will create a backup mechanism, and it will be a much more advanced script as it will include exception and error handling and other mechanisms to ensure proper Arista script that can be actually used and executed in production environments as well. For this video, if you have any questions, please do not hesitate to comment them below, and just make sure to subscribe to my YouTube channel, and you can also follow my Instagram page of SDNBit, and I have also opened the LinkedIn page where you can also contact me and send requests if you need anything or if you have any project on your mind. Thank you very much for watching again. I will see you in the next video. Have a nice day.